Hello and welcome back to this wonderful channel called Physics Man, your one-stop solution for everything related to physics. If you haven't subscribed to this channel yet, please do so and press the bell icon so that you don't miss any update. And if you like this video, give me a thumbs up. It means a lot to me. And in this video, I'm trying a new scene transition. Give me a feedback about that in the comment section. Now, without any further ado, let's continue with our read along, NCERT read along of chapter number 1, Electric Charges and Fields. In this video, I'm going to discuss example 1.2. In this question, it is mentioned that if 10 raised to 9 electrons move out of a body to another body every second, how much time is required to get a total charge of 1 coulomb on the other body? We have already learned an equation Q is equal to NE, where here Q is not the total charge, it is the charge coming out per second, because here number of electrons per second is given. Okay, so we can find Q is equal to what is total number of electrons coming out per second? That will be 10 raised to 9 multiplied by what is the charge of an electron? It is 1.6 into 10 raised to minus 19. So we are not considering the polarity, we are talking about the magnitude. That's why we have not taken minus sign over here. So this will come out to be 1.6 times 10 raised to 9 multiplied by 10 raised to minus 19. You will get it as 10 raised to minus 10, and this will be coulombs per second. Remember this, it is per second. Now if you want to find the total charge, how will you find it? Total charge, I am writing it as capital Q. How to find the total charge? How to find the equation for total charge? Example, take an example of one apple is falling off a tree in every second. So 1 second, one apple is falling. Tell me how many apples would have fallen after 5 seconds. You will clearly get it as 5. How did you get it actually? You multiplied the time with the number of apples falling per second. In a similar way, the total charge would be charge per unit second multiplied by the time. So this is how you form an equation. But they are asking to find the time. The time is what is to be found out. So we can rearrange this equation as T is equal to capital Q divided by small q. But do you have these values? Do you have these values with you? Yes, the total charge required is 1 coulomb. So Q is 1 coulomb divided by what is small q? We have already found it as 1.6 multiplied by 10 raised to minus 10. If you find this, it will come out to be 6 into 10 raised to 9. 6 into 10 raised to 9. Okay, approximately 6.25 into 10 raised to 9. Okay, so that's the time and it is in seconds. But if you convert it to years, how do you convert it to years? We know that if we want to convert it to minutes, we know that 60 seconds is 1 minute. So how do you convert from seconds to minute? You have to divide by 60. So if you want to convert it to years, this will come out to be 6.25 multiplied by 10 raised to 9 seconds. It will be converted to minutes by dividing 60. If you want to convert it to hours, you have to divide by 60 again. If you want to convert it to days, you have to divide by 24. If you want to convert it to a year, you have to divide by 365.25 or just 365. So if you do all these things, you will get it as 200 years, approximately 198 years or 200 years. Okay, so that many years it will take for 1 coulomb of charge to accumulate on a body. So that means 1 coulomb is a very large unit. Now I'll just read what is written over here. In 1 second, 10 raised to 9 electrons move out of the body. Therefore, the charge given out in 1 second is 1.6 into 10 raised to minus 19 multiplied by 10 raised to 9. That's what we have done here. And then that will come out to be 1.6 into 10 raised to minus 10 coulomb. The time required to accumulate a charge of 1 coulomb can then be estimated to be 1 coulomb divided by 1.6 into 10 raised to minus 10 coulomb per second. That's what we have done here. And that will come out to be 6.25 into 10 raised to 9. That's what we have got here. And if you want to convert it to years, you have to divide by 365, 24 and 60 multiplied by 60, which is nothing but 3600. So if you divide all these things, you will get it as 198 years. And yeah, that's what we get from this. So that can be approximated as 200 years. So thus, to collect a charge of 1 coulomb from a body from which 10 raised to 9 electrons move out every second. It's not a small amount of electrons that are coming out, okay? Every second, 10 raised to 9 electrons. Again, as you might have seen in the previous video, I've talked about 1.6 into 10 raised to minus 19 by putting out zeros. That means in a similar way, this is like 1 followed by 9 zeros. It's not a small joking matter. So 10 raised to 9 electrons are coming out every second. Still, it would take 200 years to form 1 coulomb of charge. So that much huge is the SI unit of charge. That is why there is no that's why it doesn't come as a shock to us that we use microcoulomb or millicoulomb or even nanocoulomb as the units, as the practical units. 1 coulomb is therefore a very large unit for many practical purposes. It is, however, also important to know that know what is roughly the number of electrons contained in a piece of 1 cubic centimeter cube of a material. A cubic piece of copper of side 1 centimeter contains around 2.5 into 10 raised to 24 electrons. So 1 centimeter cube of copper contains this many electrons. Got it? Again, it's not like okay, this is 10 raised to 9 and this is 10 raised to 24, only 13 difference or 15 difference. That's not how it is. It's like 15 zero difference. So this is 2.5 I mean 25 followed by 23 zeros. That's a huge number. Okay, so that's it for today. We'll continue with example 1.3 in the next video. So until we meet again, it's goodbye from me and happy physicsing.